Scientists have identified over 4,000 planets in this cosmos to date. Advanced technologies such as the Hubble Space Telescope and, more recently, the billion-dollar James Webb Space Telescope have and are going to make significant contributions in this area. In all these discovered planets, is there a world like Earth? Or is there water and air on any of these newly identified planets? Does life exist there already? Or can we start a new life there? These concerns have piqued the interest of scientists, yet even advanced technology have been unable to answer them. However, there is something much bigger than the gigantic James Webb Space Telescope that will aid scientists in discovering what cannot be discovered today or in the future without it: the LUVOIR Telescope. Welcome to Cosmos Lab, your one station for all the news from space. Join us in today's video to find out about the telescope that is even bigger and better than the recently launched JWST. The state-of-the-art James Webb Space Telescope has been launched, so what's next for astrophysics done from beyond Earth's surface? Well, their work is not done yet. The 4,000-plus planets discovered so far have been unnoticed characters on the cosmic stage, despite the recent frenzy surrounding the quest for faraway exoplanets. Except for a very few big things photographed by ground-based observatories, nearly all exoplanets have only been spotted when they dim the light of their host stars for a brief period of time, or when their gravity causes the star to wobble in a particular fashion. Scientists can determine an exoplanet's orbit, radius, mass, and density using these patterns, and a few other approaches, but not much else. The planets are still small black shadows, as one field researcher puts them. Scientists, as known for their curiosity, want more. They want to determine the chemical composition of the planet's atmospheres, whether liquid water is present on their surface, and ultimately, whether these worlds are habitable. For this purpose, many telescopes, including the Hubble, are launched that have amazed scientists with their discoveries. And now, the biggest telescope ever, the successor of Hubble, the James Webb Space Telescope, that is expected to even discover the aliens. To find the answers, scientists need something more strong. Every 10 years, the whole astrophysics community gathers to submit proposals for which projects would provide the most scientific benefit to the discipline as part of the National Academy's Decadal Survey. This time, to determine the next more advanced and more strong telescopes, NASA commissioned two significant studies that took 4 years to complete, involving big teams of scientists and engineers. The National Academy of Science is currently reviewing the findings as part of a decadal survey for astronomy and astrophysics. The survey came up with the most ambitious, most complex, most expensive, and most revolutionary of all telescopes, the LUVOIR, for Large Ultraviolet Optical Infrared Surveyor. If scientists want to know if life exists on different Earth-like planets, they'll need LUVOIR or something very similar at some point. As we talked about in our previous videos, the gigantic James Webb Space Telescope is essentially a beefed-up Hubble Space Telescope. It's so huge that its mirror pieces would have to be folded origami-style to fit into a single rocket fairing. The LUVOIR is even bigger. Its concept study aims for a huge telescope mirror with a diameter of 15 meters, almost 50 feet. That's 6 times the size of the Hubble Space Telescope's mirror, and more than twice the size of Webb's 6.5-meter telescope. LUVOIR's most ambitious design would include a mirror the size of a carnival Ferris wheel. Astronomers anticipate that this multi-purpose telescope will be able to accomplish a range of astronomical science goals, including observing Jupiter's cloud tops with a 15-mile or 25-kilometer resolution and searching for biosignatures in the atmospheres of other planets. So what other discoveries is this massive telescope going to make? According to the study reports, the observatory's main purpose is to speed up the search for small, faint, Earth-like exoplanets orbiting Sun-like stars, in the hopes of finding those that could support life. Another goal is to enable a wide spectrum of astrophysics research, from the reionization epoch to galaxy creation and evolution, as well as star and planet formation. It would also be able to conduct powerful imaging and spectroscopy observations of solar system bodies. One of its key science goals would be to find and characterize Earth-like planets orbiting nearby stars. The telescope has enough power to locate about 100 of these exoplanets, which can subsequently be studied in detail to look for signs of life outside of our own solar system. According to Martin Barstow, who is the professor of astrophysics and space science at the University of Leicester, was appointed by the UK Space Agency as an external observer to the LUVOIR study team. Earth-like planets orbiting other stars are enormously difficult to find, and detecting them is beyond the capabilities of our current planned space missions. But we are developing the technologies to carry out this search and are close to having the tools ready to fly in space. A mission like LUVOIR is the tool we need and is a tremendously exciting prospect. The search for habitable worlds and life elsewhere in our galaxy is, in my view, one of the most important scientific quests. Barstow is also co-author of the report backing the proposal and is chair of the Space Telescope Institute Council, which provides oversight to the body that operates Hubble and will operate JWST. Showing the excitement and faith in the design, he said, "I will look forward to having that answer to the question, are we alone, within my lifetime?" The question here is, how is this telescope going to perform the functions and discover such distant objects? The answer obviously lies in its mirror. With a segmented telescope assembly and a massive sunshade to be deployed in orbit, the initial designs are comparable to JWST. However, LUVOIR would have a segmented mirror with a diameter of up to 16 meters compared to JWST's current record of 6 meters. One thing that is going to make you a fan of this telescope, as stated by Forbes, is that the image being able to point your telescope at every galaxy in the universe, an object that is normally 100,000 light-years large, and seeing features as small as 300 light-years across, no matter how far away it is. LUVOIR would show a galaxy the size of the Milky Way as at least 400 pixels across, with over 120,000 pixels of usable luminous information in every frame, regardless of how far away it is from us. Isn't that amazing? The LUVOIR study team has produced designs for 2 variants of LUVOIR, one with a 15.1 meter diameter telescope mirror called LUVOIR-A, and the other one with an 8 meter diameter mirror called LUVOIR-B. LUVOIR is the most recent form of a real successor to Hubble Space Telescope, and it is planned to observe targets in UV, visible, and infrared wavelengths, as opposed to JWST's only infrared capacity. Coming toward the design, to permit direct observations of Earth-like exoplanets, LUVOIR would be equipped with an internal coronagraph instrument named ECLIPSE, Extreme Coronagraph for Living Planetary Systems. For the smaller LUVOIR design, an external starshade is also available. The LUVOIR design integrates 3 principles to achieve the extraordinary wavefront stability required for chronographic studies of Earth-like exoplanets. First, vibrations and mechanical disturbances are kept to a minimum throughout the observatory. Second, both the telescope and the coronagraph use active optics to regulate several layers of the wavefront. Third, to control thermal disturbances, the telescope is actively heated to precise 270 Kelvin or 3 degrees Celsius. The LUVOIR Technology Development Plan is supported with funding from NASA's Astrophysics Strategic Mission Concept Studies Program, the Goddard Space Flight Center, the Marshall Space Flight Center, the Jet Propulsion Laboratory, and related programs at Northrop Grumman Aerospace Systems and Ball Aerospace. The massive James Webb Space Telescope took $10 billion to come to life. How much is the LUVOIR, which is even bigger and bigger, going to cost? For LUVOIR-A, the initial cost estimates are approximately $10 billion US, with lifetime cost estimates of $18 billion to $24 billion. When it comes to LUVOIR-B, which was designed to launch on a heavy-lift rocket with an industry-standard 5 meters or 16-foot diameter launch fairing, lifetime cost estimates range from $12 billion to $18 billion. If everything goes accordingly, the massive telescope scores well in the funding competition. The Mega Space Telescope will launch sometime in the 2030s. It takes a lot of time and money to get definitive answers to the most important issues of all. When the prize is discovering there's life on that planet orbiting another star right over there, it's apparent that LUVOIR is the one telescope we all need to work together to create. What do you say? Will this telescope be able to deliver what it is promising? Are we going to find a planet that would be our second home? Share your views in the comments section below. If you like the content, do give it a thumbs up. And don't forget to subscribe to the channel and click the bell icon for the update on upcoming space videos. Until then, have a great day, and thanks for watching.